Hi guys, so we are on the mid-chapter checkpoint, page 405 for chapter 9. We have choose the best term from the box. Blank is the horizontal number on the coordinate grid. So horizontal is the one that goes across like this. So that would be the x-axis. So x-axis. The one that's vertical that goes up and down, that is the y-axis. Number 2, a blank is a graph that uses line segments to show how data changes over time. That would be a line graph. Because we have lines which are connecting the graph points. Number 3, how many kittens weigh at least 3/8 of a pound? So everything that is 3/8 and higher. So let's look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 kittens. What is the combined weight of all of the kittens? So, let's see. 1/4, 2/4, 3/4. So that is 3/4. 3/3, 6/3, 9/3. Sorry, 6/8. These are 3/8 each. 3/8, 6/8, 9/8, 12/8. So 12 over 8. 1/2, 2/2, 3/2. 3 over 2. 5/8, 10/8. 10 over 8. Okay, so we need to add all of these together. Okay, so let's see. I'm actually going to do this. I'm going to simplify the 12/8. I'm going to take a 2 out of each of those. And I'm going to make it 12 divided by 2 is 6 over 8 divided by 2, which is 4. So 6/4. I'm going to multiply this 2 by 2 to get 4. Whatever I do to the bottom, I have to do to the top. 3 times 2 is 6. Then here, I can once again divide out a 2 to make the bottom a 4. And so the top 10 divided by 2 is 5. So I now have 3/4, which stays the same, plus 6/4 plus 6/4 plus 5/4. So 3 plus 6 is 9, plus 6 is 15, plus 5 is 20, divided by 4 is 5. Okay? Because remember, when we add stuff together, we have to do the same denominator, common denominators. What is the average weight of the kittens at the shelter? So 5 divided by however many kittens we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I think I'm going to have to do 5, enter 12, and then draw a line between the two. Yeah, so 5/12. Okay, this right here is why I'm always using paper to write on instead of this, because it doesn't, and this doesn't work as nicely at all. Okay. Where is each given point at? So point A, now we're getting into the real reason why I'm on here instead of writing it on a piece of paper. Point A goes 1 up to 6. So open parentheses, 1, comma, 6. B is 2 over to 2. So 2, comma, 2. Remember, bottom first, then side. So how far across, then how far up. C is 4 across and then 4 up. So it goes 4, comma, 4. D is 0 across and then 3 up. So it is 0, comma, 3. Now we need to label these points. E is at 6, comma, 2. So we go across 6, and then up 2, and we end up with an E there. Okay. F is 5, comma, 0. So across 5, up nothing, and so we end up with a 0 there. 5, comma, 0. That's our F. G is 3, comma, 4. We go over 3, up 4. So that is where we end up with G. H is 3, comma, 1. So we go over 3, up 1. And that is where H ends up. All right, pause it if you need to. I'm moving on to the next page. All right, so I am on page 406. Jane, number 14, Jane drew a point that was 1 unit to the right of the y-axis and 7 units above the x-axis. So 1 unit to the right, 1 unit to the right, and then 7 units above. Can I even do that? Probably not. So 1 unit to the right and then 7 units above. 1, 2, 3, 4, 5, 6. Yeah, that's not going to work. All right. So 1 unit to the right. Oh, you know what? I can do it this way. 1 unit to the right and then 7 above. 1, 2, 3, 4, 5, 6, 7. Which means our x point ends up being 1 and our y point ends up being 7. So we can write it as 1, comma, 7. All right. So this graph shows the amount of snowfall in a 6-hour period. Between which hours did the least amount of snow fall? So there's a point at which no new snow is coming. Every time it goes up, that means new snow is coming. But when it goes flat, that means there's no new snow. So when do we have it flat? When is there no new snow? Between the 2 and 4. So 2 to 4 hours. That's where there was no new snow. Number 16, Joy recorded the distances she walked each day for 5 days. How far did she walk in 5 days? 1/3, 2/3, 3/3, which is equal to 1. 1/2, and then 2/3. So we have a 1 plus 1/2 plus 2/3. We don't need to worry too much about the 1. The 1 is fine the way that it currently is. We're not super concerned about that, but we do need to change these so that they are different. 2 and 3 have nothing in common with each other, so we're going to have to multiply them by each other. 2 times 3 will give us a 6. 1 times 3 will give us 3, because remember, whatever we do to the bottom, we have to do to the top. 3 times 2 will give us 6. 2 times 2 will give us 4, because whatever we do to the bottom, we have to do to the top. So 3 plus 4 will give us 7 over 6. Now, the problem here is 7 over 6 is an improper fraction. Can't leave it that way. I have to divide it out. So 6 goes into 7 how many times? Once, because 1 times 6 is 6. 7 minus 6 is 1. So we're left with 1 and 1/6 plus that 1 that we started with. So we add that together. 1 plus 1 is 2. And then we're left with our fraction of 1/6. 2 and 1/6. And yes, that's a very funky looking number. But we are done with the mid-chapter checkpoint. So talk to you guys later. Bye.